Alright, lesson worksheet 2. I was just watching lesson worksheet 1. I am sorry for the screaming children that sound like they're getting murdered in the background. You know, life with a 2.5-year-old and a 1-year-old gets pretty wild. Alright, 3 variable system. You know, an extra variable, double the fun here. Alright, so the situation is the exact same idea. You do elimination and you get rid of variables. Elimination, get rid of variables. So the goal is to eliminate. We want to eliminate, to make this into a 2-variable system. So we want to do elimination so we can make this into a 2-variable system. Now, does it matter which variable you choose to get rid of? No, it does not. So I'm looking at this and I think I'm going to get rid of y. That's what I'm going with. So I got equation 1, equation 2, and equation 3. So if I take equation 1 and multiply it by 3, and I take equation 2 and multiply it by 2, I'm going to have 9x plus 6y minus 12z equals 3 over 10x minus 6y plus 14z equals 56. That leaves me with 19x plus 2z equals 59. So there I have it. There's my xz equation. Now I need to use equation 1 and 3 or equation 2 and 3 to do the exact same thing. Eliminate y. So if I go in this situation, equation 1 and 3. Equation 1 I can multiply by 2, and I do nothing with equation 3. So I'd have 6x plus 4y minus 8z equals 2 over 2x minus 4y plus 3z equals 17. 8x minus 5z equals 19. There we have it. Now I've set this up so that I have an XZ system. Right? XZ system. So I'm doing exactly what we were doing on the previous worksheet. So I look at this, I'm going to get rid of z. So I'm going to multiply this equation by 2 and this equation by 5. So I get, do I want to do that? Times 2 times 5. So I get, where am I at? Equation 4 times, okay, so I get 95x plus 10z equals 295 over 16x minus 10z equals 38. Alright, so I work my way down. 111x equals 333, x equals 3. Awesome. Now, being honest, with 3-variable systems, you very rarely get crazy decimals. Because if you had crazy decimals, the nice, clean, integer original equation would probably never work. Alright, so I got x equals 3. So what am I doing now? I got to work my way back up. So if I take my x equals 3 and plug into this equation, now I have 24 minus 5z, not 15, I was jumping ahead there with that, minus 5z equals 19. So I'd have negative 5z equals negative 5, z equals z equals 1. Alright, so I got x, I got z. I'm moving on up to get y. So I'm going to use equation 1, 9 plus 2, why can't I write? 9 plus 2y minus 4 equals 1. 2y equals negative 4. Y equals negative 2. There we have it. So we work our way down to solve for one variable to then work our way up. So what is our answer? 3, comma, negative 2, comma, 1. And this is a consistent independent answer because there is one point that all three of these equations cross at, and that is our solution. Now, could you have done this by picking a different variable to eliminate? Yes, if you started off by eliminating x or eliminating z, this will work out. That's one of the annoying things to do with these is to make sure that, as we work as a class, that everyone do the exact same thing. It's a little tricky. All right, looking at the second one. What makes this one annoying is that it's not organized in a way that's going to help us out. The x's, the y's, the z's are not set up in a way it's going to work here. So we have to reorganize. So really, you could take your first equation and write it as 2x minus 3y plus 6z equals negative 21. Alright, so looking here, being that I see a solo z, that's the first thing I'm going to get rid of. That's just going to make things easier. What just happened? Why did it move? Alright, there it goes. So I have a solo z, that's going to make my life easier. So I'm going to take equation 1 and equation 2 and multiply equation 2 by negative 6. So I have 2x minus 3y plus 6z equals negative 21. Then I have 30x minus 24y minus 6z equals negative 18. So I work my way down. 32x minus 27y. Why can't I write? Stop! Come on! 27y equals negative 39. So now I gotta eliminate y. I gotta eliminate z again. So I'm going this situation with equation 2 and 3. So equation 2 in this problem, I'm multiplying by negative 4. So I'm going to have, I got 20x minus 16y minus 4z equals negative 12 over 7x minus 7y. Oops, I didn't mean to multiply by negative. Times 4. So that would be, if I multiplied 20 times negative 20x plus 16y plus 4z equals 12. Sorry about that. Negative 4z equals negative 6. Straight down, I get negative 13x plus 9y equals 6. Alright. Time to eliminate our variable. I see it right there. 9y, negative 27. Multiply this equation by 3. 32x minus 27y equals negative 39 over negative 13x. Nope, forgot to multiply by 3. Negative 39x plus 27y equals 18. Negative 2x. Oop, that's not a 4, that's a 9. Negative 7x equals negative... I keep messing up, that's a 9. So negative 21, x equals 3. It's hard to write on the iPad. All right, plugging in, I got negative 39 plus 9y equals 6. 9y equals 45. Y equals 5. And then going up the whole way, pick an equation, go with whatever equation you want. I got negative 5. I got negative 15 plus z plus 20 equals 3. Z equals negative 2. So my answer, 3, 5, negative 2, and it's a consistent independent answer. Now, what is nice about this? The nice thing about this problem is that we can set this up in a way that we can use our calculator. So we're going to use what's called a matrix. Now the first thing I do is we have to reorganize this so that we have all the correct variables lined up together. So I'd have 2x minus 3y plus 6z equals negative 21 over negative 5x plus 4y plus z equals 3. 7x minus 7y minus 4z equals negative 6. All right, we got it lined up. Now to actually make a matrix, we remove all the variables and equal signs. So the top row of our matrix is 2, negative 3, 6, negative 21 over negative 5, 4, 1, 3 over 7, negative 4, negative 6. This is our matrix. Right. It is what's said to be a 3 by 4 matrix. It's always going to be rows by columns. Rows by columns, 3 by 4. Right. And we are actually going to use our calculator now in this situation to solve the matrix for us. Okay, here we go. Where's the camera? Okie dokie. So, try my best here, people. On my calculator, if I hit second, x and negative 1, the word matrix is right above it. Now, you may have stuff on the screen. You may not have stuff on the screen. Whatever it is, it doesn't matter. So when we start using it, you hit this button to use matrix 3. Right, but what we're doing right now, we want to edit one. So I'm going over to edit, and I'm going to edit matrix A. So I did something with this last year. And now, you know what? For the moment, I can make it a 1 by 1 matrix, so I clear everything out. Right, but we are working with a 3 by 4. 3 by 4, enter. And now we're going to type in our matrix exactly the way we saw it. So we have 2, enter. Negative 3, enter. 6, enter. Oh, negative 21, enter. Now, if you have a newer calculator, you probably see the entire matrix on your screen. If you have an older model one like I'm using right now, you just scroll over. Not a big deal. Negative 5, enter. 4, enter. 1, enter. 3, enter. Last row, 7, enter. Negative 7, enter. Negative 4, enter. Negative 6, enter. All right, I got my whole matrix plugged in. Right, so what do we do now? Second, quit. I go back into the matrix area. Second, matrix. I go over to math. I scroll all the way down to RREF, reduced row echelon form. I will never say that again, but yes, that's what it means. I hit enter. I go into the matrix area for a third time. I go to this, right away I was using matrix A, I hit enter. So I close the parentheses. What this is saying now is do reduce row echelon form on matrix A. Enter. Boom, there it is. Right? So that is our answer matrix. Right? So with the answer matrix, we see in this situation 3, 5, negative 2. our first column, where there's a 1 in the top left corner, says when x is 1, x equals 3. Our second row, there's a 1 for the y. When there's 1, y, it equals 5. Third row, there's a 1 where the z goes. When there's 1, z equals -2. So our calculator can do exactly what we just did by hand in the matter of seconds. Now you could do this for a 2-variable system also. So if you want to do a 2-variable system, second matrix, edit. A 2-variable system is going to be a 2 by 3 matrix. So the ones that we did on the previous pages, you could plug in right here. And so looking forward to our future exam, you will be able to use your calculator for part of it and not part of it. So, being able to solve a 2-variable, 3-variable by hand and using a calculator is key to what we're doing. All right, so on the lesson worksheet that you're on right now, there's step-by-step instructions that are pretty good. I hope this video part helps, but let's keep going. All right, so back to the worksheet. All right, so scrolling through, there's instructions. Why can't I change page? All right, there we go. All right, so solving the system by hand, I feel like a lot of you are going to figure out, have that idea. But I just want to show you, if we used our calculator for this one, we would get 1, 0, -2, 3, 0, 1, 2, 2, 0, 0, 0, 0 as our answer matrix. That is not an acceptable answer matrix. When you have an answer matrix, the only way it's an actual answer is when we have the diagonal ones with the zeros. So if you have a matrix that looks like that, that is your answer matrix. If we have something that looks like this, with the zeros on the bottom, this is a consistent dependent answer matrix. This means that somewhere in the problem, we have the exact same lines. Right? Somewhere in the problem, we have the exact same lines. If we had something like this, if you had a matrix where the bottom row was 0, 0, 1, meaning we did not have the diagonal ones followed by the answers, this would be inconsistent. So if we look up at this problem, if I look at problem 3 is 2x minus 4z equals 6. If we take equation 3 along with equation 2, equation 2, and we put those together by multiplication, we'll see that they actually are the exact same line. All right, so if I divided this one by 2, I'd have x minus 2z equals 3. If I divide this equation by 3, I would have x divided by -3, x minus 2z equals 3. So equation 1 and equation 3 end up being the exact same equation, which, as we've learned, consistent dependent. All the points that work on those lines are mathematical solutions to this system. All right. Hopefully this video you found helpful. Hopefully you found the first video helpful. Work on homework number 2. Work on homework number 3. When I see you all on Wednesday, we'll check things over and we'll be good to go.